Hello. So in this video, I would like to discuss about stoichiometry, especially in chemistry. It's actually a quantitative study that describes the amount of chemicals in a reaction. So we try to calculate and estimate the amount of chemicals involved in a reaction. Say we have a reaction of combustion of this material. It's carbon material combusted by oxygen. It will create carbon dioxide. For example, we are given an amount of carbon here, but then it's going to be burned with a certain amount of oxygen as well. The form factor of carbon is usually solid, and the form factor of oxygen can be usually gas. So usually for solid, we use like grams, for example, as a weight. While for oxygens, we typically use volumes, like liter. Now, in this case, in this chemical reaction, we see the needs of creating a simplified unit so that this reaction will be easier for us to understand and to discuss the amount of something there. Because grams, if we talk that some amount of grams need to be mixed with certain amount of volumes, I think that's going to be not always easier. So in this case, chemists devise a variable called the mole, with the symbol of N. So it's called the mole. The mole is actually a variable. So we have the triangle of mole. Yeah. Mole M over MR. So we can actually formalize the mole as the mass over the atomic mass or the molecular mass of something. In this way, because all the chemicals, they have their own atomic mass based on periodic table, we would be able to create a single unit that can be used in reactions regardless of the form factor. It's going to be standardized because it's divided by the atomic mass. So remember that when we want to do chemical calculation, the mole is the most important unit to be used here. Let's say that here we have like 24 grams of carbon. So if we want to find the moles of carbon, which is 24 grams, we just need to plug in the numbers. 24 grams divided by the atomic mass of this thing. So only the carbon. And if you see on the periodic table, carbon is actually 612. Remember that 6 is the atomic mass, atomic number. It tells us about the number of protons and electrons contained in the carbon, while 12 is actually the mass number. So this is the number that we use to determine the atomic mass. Since this carbon only composed of one carbon atom, we use 12. So we will get 2 moles. So in this reaction, we will be able to deduce that the carbon is actually 2 moles, oxygen and carbon dioxide in this reaction. Now, actually, I would like to give an analogy. For example, one man and one woman becomes a couple. And let's say that in that party, we have 3 men. Then I would ask, how many women should I pair with that 3 men in order to make appropriate amount of couples? So the idea is that one man, one woman becomes one couple. But then the actual condition is 3 men. So of course, we know that we need to pair 3 women in order to make 3 couple. But how can we actually come up to this solution? It seems that from this formula, from one man, one woman, one couple, we multiply everything by 3. Yeah. Since this is a multiplier of 3, then we also multiply this by 3 and multiply this by 3. Let's write another example. For example, like one man and 2 women becomes one group. So one group will consist of one man and 2 women. But let's see, we have 4 men. Yeah. So this is the formula. One man, 2 women become one group. But the formula is 4 men. So actually the condition, the condition is 4 men. So the question is, how many women should we pair with these 4 men in order to make the appropriate number of group? If every one man would need two women, so of course four men would need twice the amount as well. One need two, so four needs eight, and they would produce four group as well. So we come to the same conclusion here, like the previous formula, that the number of something to based on the number of coefficients. Okay. So in this formula, carbon plus oxygen becomes carbon dioxide. Yeah, we can go back to that formula again. You can write it again. Becomes carbon dioxide. If we know that the carbon here is 2 moles exactly, Mr. How do we get 2 moles actually? We get 2 moles because of the mass calculation from 24 grams. Typically, it can be given by the question itself. So the question can give you the mass, and then you can calculate the moles. So for example, here you have the carbon is 2 moles. So if the question asks you to deduce the number of oxygen and the carbon dioxide needed, then yeah, we see the coefficients. Oh, the formula says one carbon atom would bind with one oxygen molecule to form one carbon dioxide molecule. So everything here is one. Because one item has the price of 2 moles, and since everything is one, I suppose this would also be 2 moles. And this would also be 2 moles. The same, since the coefficients are all the same. But if the coefficient is not the same, then you need to multiply. For example, I have this. Hydrogen gas plus chloride gas becomes 2HCl. Yeah. So this is already a balanced equation. Let's say that this is 2 moles. Let's say that this is 2 moles. If we don't have anything in front, the coefficient usually 1. So if we want to find chloride, we see that the coefficient is the same, so 1 and 1, so it will be also 2 moles. While this one is 2, so if we want to find this one, it will become 4 moles. Based on the triangle, the first triangle, the mass triangle, the mole triangle, if we have the mole, we can find the mass because we can find the molecular mass or the atomic mass from the periodic table. So for example, here the question asks you to determine the mass of carbon dioxide. You can just use the formula multiplied by the MR of carbon dioxide. So the mole will be 2 moles. The MR of carbon dioxide will be, so carbon 12 and oxygen 16. But since we have 2 oxygens, we have 1 more. We add everything up, we get 44. So 2 multiplied by 44, we get 88 grams. So this is the mass of carbon dioxide produced from 2 moles of carbon, or 24 grams of carbon. This is the first triangle, which is called the mole triangle. And the formula is as such. Actually, scientists has also been wondering whether there is a connection between the mass and the volume. Because sometimes we are not only dealing with solid things, but we are also dealing with liquid things or gas. So for gas, actually, scientists have find out that the number of moles, it seems to be proportional with the volume of a gas. In room temperature and pressure condition, or RTP we say, the number of moles would be equal to volume divided by 24. While for standard temperature and pressure, so STP, the number of mole would be equal to volume divided by 22.4. So what does it mean? So for example, we have 1 mole of something here. For example, we have 1 mole of something. The volume will be exactly equal to 24 liter or 24 decimeter cube in room temperature and pressure condition. So this is the second triangle that we need to learn, the connection between the mole and the volume. So 1 mole equals 24 decimeter cube. This is typically only for gas. Gas only. So if you are given a volume of a solution or a liquid, then you cannot use this formula. This formula only for gas. Yeah. So for example, the question use similar equation like we used before. So they give you the volume of oxygen. For example, they give you 4.8 decimeter cube. And then they ask to find the mass of carbon. So how would we do such question? So the main idea of stoichiometry is actually changing everything that is known by the question, that is provided by the question, into moles. So here, 4.8 decimeter cube, we can change into the mole, which is volume divided by 24 decimeter cube. 4.8 decimeter cube divided by 24. So we would get 0.2 mole. Because the mole of oxygen is zero point 0.2 and the coefficient are all the same, the mole of the oxygen would also be the same as the mole of carbon and the mole of carbon dioxide. So the mole of carbon will also be zero point 0.2 mole. So if we are asked to find the mass of carbon, will be mole of carbon multiplied by the MR of carbon. So 0.2 mole multiplied by carbon 612. So will be 2.4 grams. It seems that 2.4 grams carbon is needed to be able to combine with 4.8 decimeter cube oxygen to form carbon dioxide. We can even find the mass of carbon dioxide as well. So you can try that if you want. So guys, we've discussed two triangles, the mole triangle and the volume triangle. Now, I would like to provide another triangle, which is actually related to the number of particles. So technically, reaction between molecules happen because the particles are colliding into each other. So there are some crash, some collisions between atoms. And in order to create appropriate number of molecules, the correct number of atoms should collide. That is why sometimes number of particles, it was actually used by scientists back in the days. But since the number are so big, so it's not very convenient for us. That's why we use the mole, right? So the mole is also a very nice version of the number of particles because it simplifies the calculation. The number of particle in 1 mole is exactly 6.02 10 to the power of 23 particles. This large figure we call the Avogadro number, Avogadro constant, or Avogadro number. Typically, we have the symbol for it, which is L, and the number of particle is N. So the formula would be number of particles would equal to the mole multiplied by the Avogadro constant. So the triangle would look something like this. Yep, something like this. Sometimes question would also provide the number of particles in order to confuse you. For example, like carbon plus oxygen becomes carbon dioxide. Then the question provides if there is 3.01 particles of carbon dioxide, what would be the mass of carbon? Now, the first step of doing this is always changing anything that we know, if possible, to the mole, so that we can use that mole to find the other thing. From this triangle, we know the big N or the number of particles, which is 3.01 10 to the power of 23 particles. That is why now we would like to convert it to the mole. So the mole would equal this divided by the Avogadro constant. So it will be equal to half or zero point 0.5 mole. Since this is zero point 0.5 mole and all the constants are 1, so we can assume that this is also zero point 0.5 mole. That is why the mass of carbon would equal to the mole of carbon multiplied by the MR or the atomic mass of carbon. So zero point 0.5 mole carbon 12 will be equal to 6 gram. Okay? So provided the number of particles, you could still do calculation that gives out the mass of something. So far we have 3 triangles, guys. So the mole triangles, we have the volume triangle, typically for gas, and we have the number of particles triangle for everything. As a final one, it's actually the concentration triangle. The concentration triangle, the symbol, in order to not confuse it with mass, it's actually C or concentration, which is mole over volume. And typically, this is in liquid or solution. The concentration describes the number of mole of something in a specific amount of volume. For example, you try to dissolve sugar in a becker glass full of water, then you will be provided with the concentration of that sugar in that container. Or, for example, you try to dissolve salt in a becker glass full of water as well, then you'll be able to determine the concentration of salt. So remember that the concentration always equivalent to the mole divided by the volume. And the mole, the unit is the mole, and the volume needs to be in decimeter cube. So the unit is mole over decimeter cube. This is the unit. For example, provided you have a sodium hydroxide and the mass is 4 gram, we try to dilute it, dissolve it in a bigger glass, let's say 500 centimeter cube. The question asks, what is the concentration? How would we be able to find the concentration? So we know that the concentration of such thing would be mole over volume. How can we find the mole from this information? I think the mass is provided here. So from the mass, we can find the mole. So mass over MR. Sodium is actually 23, guys. Oxygen 16, hydrogen 1. So combined, the MR will be 40, while the mass is 4 gram. So the mole would be 0.1 mole. For the volume, it's 500 centimeter cube, and we need to change it to decimeter cube. So meter cube, decimeter cube, centimeter cube. So here multiplied by 1000, here divide by 1000. So 500 divided by 1000, it will become 0.5 decimeter cube. 0.1 divided by 0.5, it will be 0.2 mole per decimeter cube. So this is the concentration of that thing. Now, the concentration of something would not change even if you take some of the volume. Imagine that we're at the sea and then you're trying to scoop 1 spoon of sea salt water. I would suggest and I would assume that the saltiness that you feel in that spoonful of sea salt water compared to the saltiness of the ocean would be the same. So the concentration of salt would be the same because the molecules are uh, diffuse evenly, spread out evenly in that solvent. However, of course, the amount of salt that you have in your spoon compared to the ocean, the amount of salt would be different. So that's why, for example, you have this one that is actually 0.2 mole decimeter cube, and this one is 500 decimeter cube, centimeter cube, or 0.5 decimeter cube. This is the concentration, this is the volume. Let's say that you take, let's say that you take it only 100 centimeter cube or only 0.1 decimeter cube. Because you just take without mixing it with another water or doing anything else, the concentration would still be the same. It is taken from the same source. So the concentration would still be 0.2 mole over decimeter cube. That is why if we calculate, the mole would be different because the mole here, yeah, from the question that we calculate, the mole is 0.1 here. From 4 gram, 0.1. But here in the small part, yeah, in the small part, so in the big part, if the mole still 0.1. Yeah. In the small part, the mole would be concentration multiplied by volume. Concentration remains the same, 0.2 mole over decimeter cube. Volume becomes 0.1 decimeter cube. Therefore, the mole would be 0.02 mole. Yeah, it's kind of different. So then if this is used for another reaction, then you have to know that the mole is different in this case. Okay? So this sums up for the four triangles. Now I would like to speak about empirical formula and also a percentage by mass first. Yeah. So percentage by mass. In percentage by mass, actually we can try to estimate the weight of something or the percentage of something of an atom inside a molecule based on their atomic mass. So the steps are determine the atomic mass. Second step, determine the molecular mass. Third step, atomic mass over molecular mass multiplied by 100%. Let's say, for example, we have carbon dioxide. Yeah. I would like for you to calculate the percentage of carbon. How can we calculate the percentage of carbon? First, we determine the atomic mass of carbon. Here in carbon dioxide, we only have one carbon atom, so only 12. Second, determine the molecular mass. So one carbon atom plus two oxygen atom. So 12 plus 2, 16 becomes 44. Finally, in order to find the percentage by mass, we need to divide this multiplied by 100%. So we would get a number, so 12 divided by 44, around 27.3%. It means that around 27.3% of carbon dioxide are composed of carbon. Just atomic mass divided by molecular mass multiplied by 100%. That's it. That's simple. So, for example, if you have the mass of carbon dioxide is 200 grams, yeah, and you know that the percentage is 20% of carbon is 27.3%, then the mass of carbon only would be equal to the percentage of carbon multiplied by the mass of the whole carbon dioxide. So the mass of carbon would be 27.3 per 100 percent multiplied by 200 gram, it will be equal to 54.6 gram. So determining percentage by mass is rather simple. You just need to divide the atomic mass and the molecular mass multiplied by 100%. You get the percentage of a specific compound. Okay, guys? Finally, we would like to discuss about empirical formula and molecular formula. Empirical formula is the simplest chemical formula. So you simplify the numbers as simple as possible. While molecular formula, actually the molecule as it is. For example, like C2H4. Yeah. C2H4, actually you can simplify the numbers. So if you divide everything by 2, you get that they're actually CH2 and CH2, right? So just like two CH2s combined together become C2H4. CH2 is the simplest form, so they are called the empirical formula. While C2H4, yeah, it's the actual shape, so it's called the molecular formula. Back in the day, scientists, they don't really know what is the formula of something. For example, carbon dioxide. We don't know that it's one carbon and two oxygen atoms. So how would they deduce that carbon dioxide is CO2, not C2O3 or C2O5 or whatever other formula? What they did to determine empirical formula. So the first one is to define the percentage of atoms. Oh no, sorry, not the percentage of atoms, but the mass of atoms. Second, define the MR, the atomic mass. And then you can simplify. Yeah. And you divide, you divide the mass with the AR and then simplify. For example, you're given calcium and chloride. This is a simple example. So I suggest that you make a table. Always make a table because it will make your life easier. So write down mass, AR, and mole. Because mass divided by AR is mole. So let's say that you're given 0.9 gram of calcium and then you're given 1.6 gram of chloride. So this is provided by the question. For the AR, you just need to look at periodic table. So calcium is actually 2040. So 40 here. And Cl 17, 35.5. So 35.5 here. In order to find the mole, you just need to divide the mass over the MR. Will become this number. Well, for this, will become this number. So if you are asked to determine the molecular formula of the empirical formula of Ca and Cl, actually it would be appropriate to write Ca 0.0225 and Cl 0.045. This is the empirical formula or the simplest form so far. But it's not a whole number. Imagine if you go to a shop and then you're trying to buy this kind of thing and then you mention to the employee. I think they would be confused. So that is why if we see such number, because the number is not even, let's try to divide with the smallest number. Yeah, so put you divide with the smallest number. So 0.0225 divided by 0.0225 becomes 1, and 0.045 divided by 0.0225 becomes 2. Or if you want to write CaCl2. This is the empirical formula. So the empirical formula is just the mass divided by the atomic mass. You get the mole. And for the mole, you put in every atoms, then you try to simplify as much as possible by dividing it with the smallest number available. For the atomic mass, you just need to plug in into this formula. So in order to find the molecular formula, there are some steps. So the first step is to determine the empirical formula first. So in order to find out the real formula of a molecule, you need to find the simplest building block first, which is the empirical formula. After you get the empirical formula, you can start to find the molecular formula. How? We plug this formula. So the molecular formula equals to, let's say, K multiplied by the molecular mass of empirical formula. Okay? Now let's use this as an example. So this is still empirical formula. Everything that we find based on this is just empirical formula. In order to find the molecular formula, we need to have information about the MR of the molecular formula. Let's say that it is given by the question. The MR of molecular formula is 333. Let's say, determine the molecular formula. So let's plug in this formula. So 333 would be equal to K multiplied by the MR of empirical formula, or CaCl2 in this case. So Ca is 40, Cl2 is 55.5, 2 times. So it will be 71 and 40. So 111. So it can cross out. So we can have K equals 3. It means that we have 3 multipliers of the empirical formula. So this is called the multiplier. We can deduce that there are 3 CaCl2, in the molecular formula. So the real molecular formula will be Ca3Cl6. This is just an exaggerated example because I think that it would also form CaCl2. Typically, this is used more for hydrocarbons, but this is just a calculation example. Technically, if we know the molecular formula, if we know the molecular mass, then we could find how many simple building blocks are used to compose that big molecule. So we get the weight of the big molecule, and then based on the weight of one simple molecule, we can estimate the number of simple molecules used to compose this big molecule. And it turns out that in this case, it's 3, so we get Ca3Cl6 is the molecular formula. Okay? Lastly, I would like to speak about hydrates. In hydrate, so actually, it's a compound that binds with water. So for example, like salt, because we know that salt actually takes up some moisture from the environment, like silica gels that we use to protect our shoes and bags. So typically salts can bind with water molecules. But of course, we don't know how many water molecules exactly. So for example, here we have barium chloride. Barium chloride. Barium chloride can actually bind with water molecules, but we don't know how much. So we just say XH2O. So this is a big thing. Yeah, imagine that we have a barium chloride, yeah, molecule, and this is the H2O. Yeah, I don't know how much, but let's say 2 in this case. So this will be the shape. Imagine your silica gels that you use to protect your shoes and bags. You put silica gels in your shoes, and then the silica gels will try to absorb the moisture from the environment. So, of course, the silica gels will be in a form that is hydrated. It means that the silica gels will bind with water molecules. Now, if you want to reuse your silica gels, what can we do? We can actually heat it up. So, if you heat it up, it will form the salt, but the water molecules will be released. So, of course, it will be dry, right? So, for example, here, the mass is something. Then, if we calculate the mass of this, then there will be mass of lost water. So, the mass of this will be the barium chloride, and then this will be some H2O. Yeah, I don't know how much. Yeah, depends on the H2O that is actually bound by the molecule. So, what are typical questions of this? Okay, so let's say that the question says initially we have a 2.34 gram sample of barium chloride hydrated. So it means that it already binds with H2O, but I don't know how much exactly H2O molecules in there. It says that after heating, the mass becomes only 2 gram. Yeah. So the question can ask, what is the amount of water lost? Imagine that if you heat something and then you heat it after everything becomes dry. So of course the amount of water loss, so mass of water loss would be equal to 2.34 minus 2 gram. Will be 0.34 gram. Because initially the mass is combined, the mass of the salt and the mass of water. But here, after it gets dry, 2 grams only represents this part. So the remaining part should be this, because in chemical reaction, we have the law of preservance of mass. So the mass on the left side should be equal to the mass on the right side. Because on the left side it's 2.34 gram, so the mass on the right side should also be 2.34 gram. And 2 gram is already here, so this one 0.34 gram. Okay, so with this in mind, let's actually calculate the mole. Yeah, so in order to find the number of water molecules in the hydrate, we have to calculate the mole. 2 gram and BaCl2. So 2 over the molecular mass of Cl2, BaCl2. So BaCl2 will be equal to the mass of BaCl2 divided by the mR of BaCl2. So the mass will be 2 gram and the mR will be, so 137, so around 280, guys. So later during exams or whatever, you can actually calculate this using periodic table. Because barium chloride means 1 barium atom and 2 chloride atom. So here, if we divide it, we get 0.0096, 1 mole. While for the mole of water, it will be equal to the mass of water divided by the mR of H2O or water. So we get how many? 0.34 gram divided by 18. We get 0.01887. In order to find the exact water molecules that are bound by the BaCl2, we just need to make a ratio between these two. So BaCl2, 0.00961, and H2O with the amount of 0.0117. Let's try to divide with the smallest number. So just like the empirical formula, we divide by this. Finally, we get that this becomes 1, and the number of H2O apparently 1.96 now. Let's say that 2. Okay? So then we get that the BaCl2 would bind with exactly 2 water molecules because the ratio of the moles says this. So in order to find the amount of water molecules bind in a salt, hydrated salt especially, we need to see the ratio of the moles. Yeah. So the mass we can get by actually seeing the mass changes after the heating process, subtracting it, getting the water, and then dividing everything with the molecular mass to get the mole. Okay? So I hope this video would be useful for you to review the stoichiometric, especially for assignment and also assessment. This topic covers the 4 important triangles for stoichiometry and also the percentage by mass, empirical molecular formula, and also hydrate. That's all. So thank you for watching and good luck.